This next video is going to talk about the derivatives of inverse trig functions. And when we say inverse trig, we're talking about arcsine or arccosine. And we want to make sure that we're familiar with the notation of inverse trig functions, and they're listed here and highlighted for you in yellow. When we see this little power of -1 right there, that's simply the notation for the inverse of sine. And sometimes in our AP class, you're going to see arc, A-R-C, arcsine, or arccosine, or arctangent to represent inverse. Now, there's a two-column proof right here that is essentially going to verify how we go from the function y equals the inverse sine of x to its derivative. And I'm not going to go through this in great detail. You can pause or fast forward or rewind the video if you want to take a look at that two-column proof in detail. But in the end, we get to this final box, and that box has the formula for the derivative of inverse sine or arcsine. And in addition, this chart down here has all of the formulas for the 4 inverse trig functions that we need to know and memorize for calculus: inverse sine, inverse cosine, inverse tangent, and inverse cotangent. Now, arcsecant and arccosecant I have listed down here as optional. You will not be tested or assessed on those derivatives at all throughout Calculus AB. If you'd like to know what those formulas are, you can look them up in your textbook or online. So the derivative of arcsine is essentially this formula here, 1 over the square root of 1 minus x squared. And that x really isn't an x, it just stands for the argument of the original function. Now, remember that the derivatives of cofunctions are negative. So guess what? Arccosine is the exact same thing as arcsine, but with a negative. Negative 1 over the square root of 1 minus argument squared. And then we have inverse tangent and inverse cotangent. Inverse tangent looks a little bit different. There's no square root in the denominator. And instead of a minus, we have a plus. So 1 over 1 plus x squared, or argument squared. Inverse cotangent, again, those cofunctions are negative. Same thing, but with a negative. So what I would like to do in this video is a series of examples that kind of show how we can use those formulas to find the derivative of an inverse trig function. So let's begin with this one right here. It says, what is the derivative of inverse cosine or arccosine of 2x to the third? So in red, I have here example 1. What is the derivative of arccosine 2x to the third? Well, the formula for arccosine is negative 1 over the square root of 1 minus, and then it's the argument squared. So the argument, which is the expression in the parentheses right here for the cosine, would be 2x cubed. And all of that is going to be squared. By now you know that things are never quite that simple because of the chain rule. If the argument that we're looking at or analyzing has a derivative itself, then we want to multiply by that derivative. That's our chain rule step. So I want to multiply this by what would become 6x. The derivative of 2x cubed. Oh, sorry about that. That'll be 6x squared. Okay, and then we can just clean that up and simplify that maybe as one fraction. So how about a negative 6x squared in the numerator? All of that divided by the square root of 1 minus 4x to the power of 6. And that's my derivative of inverse cosine of 2x cubed. So a couple more examples. 3 more to be precise. Here they are. Feel free to pause the video and try these on your own and see if you can get them right. The first one is inverse tangent. Let's try to find the derivative of inverse tangent. So dy dx. My formula for inverse tangent is going to be, oh, there's a 4 multiplier out there, so we'll put the 4 out in front first. So 1 over 1 plus argument squared times the derivative of the inside argument, which is 5x to the 4th. Put it all together, and it looks like we'll have a 20x to the 4th over 1 plus x to the 10th. (20x to the 4th over 1 plus x to the 10th. Next one is another arcsine. Let's try that. What is the derivative of arcsine of e to the negative 3x? So dy dx. Well, derivative of arcsine, that's going to become 1 over the square root of 1 minus argument squared times the derivative of the argument, which will become negative 3e to the negative 3x. That's an exponential function in there. And nothing really to clean up here. I would just write that as maybe a single rational expression. So negative 3e to the negative 3x in the numerator, all divided by the square root of 1 minus, and negative 3x times 2 e to the negative 6x. We use our property of exponents on that guy. There we have it. And my final example is an arc cotangent example. So find the derivative of inverse cotangent of 5x, but the whole thing is squared. That little power of 2 is on the outside. So we're going to actually do a power rule first. So we'll call that dy dx will be equal to 2 times the inverse cotangent of 5x, drop the degree by 1, multiply by the derivative of the inside. So now I get to my cotangent, or inverse cotangent. So 1 over 1 plus argument squared. That would be arctangent. I want arccotangent, and the co-functions have negatives on them. So a negative 1 over 1 plus quantity 5x squared. And then times the derivative of 5x, which is 5. So maybe the most complicated example of this video so far, but still not too bad. If you kind of take each link of your chain and put them together, we can find some success here. So I have, it looks like a 2 times negative 1 times 5 in the numerator. So negative 10. Inverse cotangent is still there. And my denominator has a 1 plus 25x squared. And that's the derivative of cotangent, inverse cotangent of 5x quantity squared. Now, the key with having success with inverse trig derivatives, and really all 6 trig derivatives, the 6 standard functions plus these 4 inverse trig functions, is that we just have to memorize the formulas. So we need to know that when we see inverse sine or arc cosine or arctangent, that we've got these new formulas in our tool belt ready to go and ready to use when called upon.